Otterly Curious is made possible in part by a grant between the HSI Equity Hub at CSU Northridge and Apple aimed to catalyze HSI programming throughout the CSU system, statewide and national. Welcome to our 5th episode of Otterly Curious. It is me, Angelica, your co-host now, because we got our new co-host, Alondra.
Hi, my name is Alondra. I'm the new co-host. I'm a marine science major, and this is my senior year at CSUMD.
Yay! Today we are here with Joe Perez. He is a current innovation scholar working with Dr. Albuquerque, and his research is all about plant physiology and how they respond to drought. Joe, can you tell me your 6-word mission statement?
Mine is creating a brighter future one seed at a time.
And what does that mean to you? Explain a little bit more in depth.
For me, because my ultimate goal here is to become a crop breeder, so I want to create, my own hybrids, my own crops, and since my research deals a lot with drought, I think it's just about the environment, saving water and stuff like that, which is what we're heading towards, especially more so now in California.
What is your research? What do you do?
My research, we have a few different projects that I've done. I've actually been here since the summer of 2024, so it's been over a year now. So I've dealt with looking at embolisms in almonds, and an embolism is when there's an air pocket in the xylem of a plant, so that water can't flow through there, and basically that's fatal to a plant. We've also looked at lettuce too, in the same realm, and then right now we're looking at grapes.
That's really cool. Can I ask what causes embolisms in plants?
It's just when there's too much water stress. Every plant has different levels of when an embolism will form. Something like a leafy green, you would assume would be a lot lower than something woody, like a grape or almond.
I recently learned that grapes is one species that can actually survive from an embolism. How does that happen? What is the plant's response in order to survive an embolism?
In order to survive, so basically there's main pathways of the xylem in a plant, and then there's branching pathways. So what it does is that it will cause an embolism on the latter end of the plant, so that it won't spread as much either. And then also there's these little kind of walls in between the xylem, so that it also won't spread throughout the xylem. So that kind of helps it not spread. And then I can't remember, but I believe it was with grapes. But some of them can actually recover from an embolism on their own. But that's still kind of new research that's been going on.
Okay, so it's not really known yet.
Yeah.
That's cool. Do you want to do that research too, looking into how grapes survive that? Or would they actually do?
Yeah, I think so. That's probably some of my next steps. I'd hope maybe, if not this semester, and probably the spring semester before I graduate, is hopefully just understanding more about the physical structures and what allows them to do that.
Can you tell me your main question for the research that you're doing now? Sorry, we kind of branched away with the questions, and then we're going to come back to what you're doing now.
Right now, this semester, I'm looking at grapes. And basically right now, we've actually got 2 different cultivars of grapes, and we're growing out several cuttings from each cultivar, and then we're going to stress the seedlings at different stages to see if different cultivars of grapes respond differently to embolisms and water stress.
Random question. What grapes are mostly planted here?
We don't have too many in the Monterey Constance area. It's a little too cold for big scale production. But we actually this summer we went down south, kind of by King City over there, to look at the vineyards over there. And then it was I can't remember exactly. I think it was more so red wine kind of grapes, though, I believe.
Oh, okay.
What everyday problems or real life issues does your work touch on, and why do you think they matter to students, researchers, or even everyday people?
For me, kind of like I mentioned earlier, it's about the whole drought and then using water better. For my past project with lettuce, we looked at to see how far we could water stress the lettuce while still having it have a yield. And ideally, we would want to do the experiment again to get better data points. But we saw that lettuce, you could stress it or decrease the water by roughly 25% and still have it be, fine in the end. And then, decrease 25% of water in the fields, that's thousands or millions of gallons of water that would be saved. So it's kind of more so on the climate change, drought, California response that I'm looking at.
Just with my background, we waste a lot of water, and when we mean by a lot of water, 500,000 acre-feet pumped annually in the Salinas Valley is being used for irrigation, where, as you just said, we do not need all that water. So it's very crucial to come up with more sustainable agricultural practices.
Mm-hmm, exactly, because also on the topic, it goes into the whole nitrate leaching, where a lot of farmers will overdo fertilizer, and then when you overdo the fertilizer, the plant can't take it up as much, and then if you add too much water, there's more runoff. So if you decrease the water, you could also decrease the fertilizer too, as a benefit.
Yeah. Also, just the human impact in the Salinas Valley with the nitrate leaching. Our farm workers are drinking dirty water when they're living near these fields. That causes many health issues with your thyroid.
Yeah.
I know you just started this project, but can you think of a setback that has already occurred in this research?
For the grapes specifically, we've noticed so far that one of them isn't rooting as well as the other one. So I believe we have about 15 little seedlings that we've cut already, and they've already rooted. But for one of them, it has I think 14 or 13 has, and then the other one has maybe about 7 or 8. So it's kind of hard to compare accurately the data between 14 data points versus 7 or 8. So we're thinking of maybe just cutting some more of the one that's lacking, or we would just have to go with a smaller sample size. We're still kind of debating.
What do you think causes your some of your plants to not sprout as much? Do you think environmental conditions, or maybe just not being actually in the field, I guess?
That could be it. Before last summer, this past summer, we were growing them in the greenhouse area here at CSUMB, but it didn't work out so well because the almonds that were there, they got virus. So we decided to just get a grow tent and put it in our lab so that we wouldn't have to deal with all that. But the grow tent has its own challenges too, because there's humidity, airflow, light, and all that.
So who inspired you to do this work?
I think it's a mix of my family and then my cultural background. With my family, gardening has been a thing since with most of my grandpa. He got that from his mom. So we've kind of just been a lot of gardeners in the family for at least a few generations. And then culturally, I have some native roots. I've been trying to get back into that, and then I've also been trying to grow more heirloom varieties. My tribes have been growing centuries, if not millennia. So that's probably my biggest pushers.
Do you know the name of your tribe that your ancestors are from?
There's a few different ones, mostly on my mom's side. My maternal line, which is kind of how a lot of tribes are chosen, as the your maternal line. Oh. And that's the Otterly tribe that my mom's from.
That's interesting, because for United States, you get your father's name.
Yeah, a lot of native tribes are more matriarchy, I'd say, so versus the patriarchy in the West.
Oh, wow. With your plant cultivation and stuff, are you hoping to kind of bring your culture back and connect that to your research as well?
Yeah, I think that's probably one of my goals too. I want to get into corn, because we grow a lot of corn here in the U.S. Mm-hmm. But the corn that we grow is actually, I believe, from the southern Mexico area, so they need a lot of water and a lot of heat. But we have a lot of native corn in the Southwest that's drought-tolerant. So I want to see how we can incorporate more of that into main-scale ag.
Yeah, that'd be really cool. Mm-hmm. Mm. How many different corn varieties are there?
In Mexico alone, I want to say there's at least 60 registered. And then in the U.S., there's probably another few dozen. And then throughout the rest of the Americas, I want to say another several dozen. So at least 200, I want to say.
Wow. That's a lot of corn.
Yeah.
How does your work fit into the larger context of the field?
In what regards?
How you connect your individual project to broader, economic or ecological goal.
It kind of ties into the whole like water usage thing that we were mentioning earlier, because like the current project right now with the grapes and then the 2 cultivars is just seeing whether one is more drought tolerant than the other, and then like maybe that could be used at some point to inform growers in South County to maybe grow a certain variety that's more drought adapted to that area.
I don't know, this might be a silly question, but is this happening in different regions or in different states of the United States, or is this problem of drought more occurring in California?
It's more so in California because we also have a really large ag business, mostly in California. So it's kind of like, on one hand, we have a lot of good soil and stuff, and also we have like a lot of droughts and like drier weather. So we rely a lot on irrigation to do our watering versus like the South, where they kind of just like rely on rainfall. But for us, we can't do that like in the summer.
Yeah, that's where our aquifers come in.
Yeah.
That are
Struggling.
to say the least.
Like, since your goal is kind of to spread or make this more mainstream, kind of go across the country, like make more people aware of drought and water usage and stuff. Obviously, in different parts of the country, like the weather is different. Like California is more prone to drought. The East Coast is more wet. Like, do you see yourself kind of expanding your knowledge of like different climates and ecosystems in the agricultural sense to be able to kind of take this other places?
I think so, because on one hand, the South is generally more wet, but also because of the climate change, there is also the risk of more droughts there. And also, even though they're pretty hot in the summer, I know that there's been more unpredictable weather with more cold snaps and so on. So maybe plants that can survive like a little bit of drought, a little bit of cold, and so on. That would be maybe something that I would like look into at some point later on.
And what do you hope to achieve with this current research topic?
That one, I think it's just kind of like the last question of just comparing the 2 varieties and then seeing which one's more drought adapted. And then, because then we also use that, because of that, that would be like a good like starting place to also like compare different varieties and so on and so forth. Because like we're just looking at 2, and then there's dozens, if not hundreds, of grape varieties that grow throughout the world. So we can also compare those 2 at some point.
I'm sorry, we should have maybe asked this sooner, but who is your mentor?
My mentor is Dr. Albuquerque here at CSUMB.
And is he currently looking for more students to be in his lab?
At the exact moment right now, in fall of 2025, no. I believe he only wants maybe 2 or 3 students at the moment, and we already have 2. So I think he's comfortable with that. But I'm not sure if the other person in my lab is a senior or not, but I am a senior, so I will be leaving by the end of next spring. So I'd say probably check into it maybe by next spring.
Yeah, and we'll be putting his directory with the description below. And what advice would you give someone trying to start their own research project?
I think just looking and seeing what resources you have available to you, and then just putting your name out there. For me, since I started last summer, it was just a quick thing from Dr. JP. He emailed me, and then I just said yes, and then I've been going ever since. So I'd say just take whatever opportunities you can.
So you still work with Dr. JP then?
No, Dr. JP is the lead for the ag program, and when I was still in Hartnell is when he sent out the emails about joining the labs here at CSUMB.
Oh, that's cool. I didn't even know mentors do that, try to recruit.
Yeah,
I know. I didn't know that either.
Yeah, I think it was new because I believe I was Dr. Albuquerque's first student, so I think it's a new kind of thing.
Wow.
Yeah, that they were doing.
That's cool.
Yeah, because Dr. Albuquerque is a relatively new professor at CSUMB, right?
Yeah, I believe so. He's been there maybe around 2 years or so.
Okay, yeah. Thank you so much, Joe, for coming on our podcast. I had so much fun learning about your research, and I was previously an innovation scholar, so it's really cool to see how each of your projects have changed from lettuce, almonds, and now grapes. I just think it's really cool what you do.
I think as a marine science person too, it's really cool getting to know the different areas of research. Like agriculture is not something I'm familiar with, but it's really cool seeing how a lot of the research questions apply. So yeah, it was really cool listening to your research.
Thank you for listening.
Bye!
Otterly Curious is made possible in part by a grant between the HSI Equity Hub at CSU Northridge and Apple, aimed to catalyze HSI programming throughout the CSU system, statewide and nationally.